are literally shaping the planet.
Purpose is the only pathway to a regenerative future.
We have a choice to stay with the status quo or to change.
What is the point of trying to be just resilient when we can actually innovate?
Adam and I have a bunch of slides, but we would like to have a conversation. So hopefully those of you in the audience still have some questions. I know there's been a lot of content over the last day and a half, and just been a tremendous amount of knowledge being shared. So let me see. Okay. So the conference is really talking about tools that we need to save the planet. And this presentation is really going to focus on functionally driven digital twin technology. And we think for a lot of different reasons that will help save the planet. So in some of the presentations that I've gone to, people have shared this systems V diagram. In this case, it has been altered to show how a systems V diagram, which comes from the systems engineering community, starts out with a project desire and ends with ultimately its use, and in some cases, decomposition. So there's two sides. There's what we call building the right building, and then building the building right, which is kind of where the name of the presentation comes from. And the idea is that the customer needs connects with the operations, the business model connects with commissioning, the spatial arrangement design connects with the assembly, and system integration connects with the manufacturing. So broadly, when you look at some of the major tools that we use, at least in the planning phase, a lot of it is Excel. And as much as we all love Excel and as powerful as it is, it doesn't have the level of sophistication and fidelity that I think we need in our industry. And a lot of people that talked about digital twins talked about the operations, but we also need to tie it back to the early phases of the project. So what I'm talking about when we're talking about functional modeling, we're going to how do you define the area that a project will serve, looking at the market conditions, leveraging any electronic health record information or publicly available information, looking at process flows, confirming the key spaces, and then optimizing those requirements. And when you're able to do that, you're able to see the functionality of the spaces over time. So a lot of us have been talking about the tools and the innovation and, you know, how exciting everything is, but I don't know if anyone really talked about when we really need to save the planet by. And I know when I started practicing, which was a while ago, everyone said it was 2000. And when I moved out to California, everyone said it was 2020. Well, it's 2020 now, and I don't think we've yet to save the planet. So I'm going to draw the line that we need to save the planet by 2100. And that's far enough out there to say it's a big date, but it's also gives us enough time to where if we don't have our act together, I think we're going to have bigger problems. And what I think continues to happen is we celebrate climbing the hills of evolution, and there's this huge mountain of change that is out there that's looming. And we definitely should celebrate these small changes that we're making, but we also need to recognize the bigger change that is out there. And the change is all tied to a frame of reference. So I wanted to start out with the frame of reference that I had growing up. I grew up in Brooklyn, and the borough president at the time when I was growing up put a big sign on both the Brooklyn and Manhattan Bridge when you're coming into town, that welcome to America's fourth largest city. And I think in New York, there's still some signs still standing. But my frame of reference was New York was the center of the universe. Well, the reality is certainly by 2100, that's going to change significantly. So McKinsey has put out many reports, and in one of them, they have indicated that more than 330 different cities of 1 million people or more are going to join the planet by the year 2100. So many of them are in Asia, but some are in the Americas, both South and North America, Europe, Africa, and Australia. And with that, McKinsey's also suggesting that we need 84 billion metric square area, or 840 billion square feet of space, which is a lot of space. And that leads to the question, do we have the capacity to create it, or do we really even need it? Which is the question that I think we could help figure out when you have a functionally driven digital twin. So one of the questions we want to ask in this presentation is, what is the right building? My background is in healthcare. Adam's background is a lot in airports, and they're highly complicated, highly functional buildings. And we're not saying that those are the only buildings, but buildings are configurable, and we need to understand how and why they're being used. So when we look at population, and this is a chart from population from 1950 to today to 2100, and this is where the world is going to be almost 11 billion people. What's interesting and not many people talk about is that other than Africa, which is this blue line here, many of the continent's populations are actually going to go down. So all of this growth that is being needed in the world may not necessarily be where we think it might be, and adaptive reuse might be more prevalent in our discussion. The other thing that I wanted to point out, not to show too much of my age, but I joined the world in 1964. And these diagrams show what is called the population pyramid. Blue is the male population, red is the female population. And this shows the different cohorts of age. And the dotted or dashed line shows the median age in that population pyramid. So in 1964, in the world, the population pyramid showed that the median age was 27. Today, it's 37. In 2100, it's going to be 47. And you might wonder, like, well, what's the big deal? Well, if you look at these charts, you'll notice that there's very few people when I came into the world in their 80s and above. Now there's some more people in their 90s and above. And when you get to 2100, there's even more. And when you look at a country like Japan, the pyramid's no longer a pyramid. So in 2100 in Japan, 1 in 12 people will be 90 years old or above. And the same is true for the US, but the ratio is going to be 1 in 25 people will be 90 and above. So what that means is these buildings that are built for young, active people are going to need to embrace people that may not be able to walk up as many stairs and move as quickly as we currently do. So Japan has already embraced some of these challenges by deploying robots in their construction community. And this is a dam that was built by Obiyashi in the Mie Prefecture, which, very heavy and hard work, but they were able to solve some of their resource constraints with construction workers by robots. And they're also deploying robots in commercial settings. The robot named Aiko is in a store in Japan. And then they're also prototyping robots when it comes to caregiving for their older population, because they know that they don't have enough younger population to take care of their senior population. So how do we come up with a solution uniformly? It's a very complex problem. The requirements aren't clear, and the solution set is almost unlimited, especially for airports and hospitals. So I would suggest that any journey, and the saying that I like by Lei Zhu, any journey of 1,000 miles begins with a single step. And what Adam and I are going to suggest is that that single step starts with understanding the rooms at what we're calling an atomic level, and understanding how a building functions, because just as how elements combine to create molecules, molecules compounds, rooms aggregate to suites or departments, and departments create buildings. So for those of you who are in the session, if you've ever broken a bone in your body, you start out by seeing the doctor. In some cases, the doctor says you don't have a broken bone. And in other cases, they have to do more work. They have to get an x-ray. In some cases, they have to do surgery. And these two charts show the utilization of those two different rooms. And you could see that the doctor's offices are very well utilized, but the surgery rooms, which are a lot more expensive, are not as well utilized as the doctor's office. So the question is, should you build 3, which isn't always going to be needed, or can you get by with 2? So that type of analysis can become a lot more complicated when you're dealing with something like cancer. So this is a similar diagram, but for stomach cancer, and it shows how the journey of the patient changes over time as the cancer metastasizes from stage 1, 2, 3, and 4. And you could see how the different rooms are aggregated. And then you could see how the rooms are used in a heat map perspective. And then not all the rooms are used for all the different cancers. So I'm not saying at all that you shouldn't build all these rooms, but I think as a designer, we should have the responsibility of informing the client of some of these metrics so that they can make better decisions. Similarly, this is the capacity of those rooms. And again, you could look at what is required, and many of these are just providing what's required, what has excess capacity, and of course, what has significant excess capacity. So endoscopy was one of those rooms that wasn't used in all the cancer types. So again, is that a room type that the client would want? So this is that methodology used on a project that we did in China, where the client asked us to really question the users as to whether they wanted all of the spaces that were requested by the doctors. So by doing this type of modeling, we were able to reduce the size of the radiotherapy rooms, which are about $10 million a piece, as well as reduce the size of the number of operating rooms. And the end result is we eliminated a chunk of the building. And what that allowed us to do is reduce the size of the hospital by 38% and increase the research building size by 42%, which is what the client ultimately wanted. And we also ensured configurability for the building. So all of these lab spaces are modular lab spaces, and they're totally reconfigurable. And all of these hospital room spaces are reconfigurable. So it's a high value investment for the owner, because one of the things about cancer is that the technology is constantly changing. So one thing that we learned in COVID-19 is that the purpose built building is really changing. And a lot of office space, at least in San Francisco, where we are, isn't being used right now. So we can't tear down the buildings, but can we repurpose them? And I want to end with this. I have two more pictures, but this is an image of a city outside of Nagasaki where they built a thriving community around a business. And after the business ceased operation, the community went dormant. And unfortunately, there are many communities and even cities around the world, it's not to just pick on Japan, that are abandoned. And I think if we're going to try and save the planet, we need to be more mindful of these functional and operational commitments that we make with buildings. So I'm going to turn it over to Adam, and Adam is going to talk about where we could implement tomorrow's methodologies today.
Thank you, Zig. Can you hear me well?
Yeah.
Okay, so Zig has mentioned at the beginning of the presentation the system V diagram, which is a framework. I would like to continue on that thought because I believe that we need to find functional frameworks to work together and look at our problems from a new perspective. This is an example of cross-pollination from the UX UI design and user-centric design, which is called the double diamond approach, where the problem solving as part of teamwork consists of first identifying what is the right thing to do, and then in the second diamond, figuring out how to do that right thing in the most appropriate, most efficient way. I really like this framework, and we've started to use it in our practice because it helps us figure out where we are in the journey of identifying the right questions and then how we can together answer those questions for a better outcome. If we move to the next slide, there's another example of a good framework, which really goes back to, in my mind, thinking based on first principles, which in this changing world is essential, in my opinion. This is by the UN identifying sustainable development goals. And if you look through these numbered goals, you can really see that the fundamentals are covered. If we are looking at these goals and we start to think about how we can create the buildings of the future or reuse the buildings that we currently have based on these goals, we really have another functional framework together that is not specific to architecture, construction, or any other discipline, but rather for the betterment of humanity. And it's a way to look at where we are regardless of what the changes are. When Zig and I were discussing ideas preparing for this presentation, we realized that the two industries that today we're representing, at least from the perspective of planning and design and construction, the healthcare industry and the airports aviation industry, have some interesting thing in common, which is that both of them are very complex systems. Both of them require buildings that are highly advanced and highly complex in terms of their building systems. And both of them were majorly disrupted by COVID-19. If we thought that we had issues or mountains of problems to solve before COVID-19 in healthcare or the airport industry, we had no idea. One thing is for sure that change is going to remain a constant. And what I like about what Zig has presented is that I was thinking about adaptability in the past, which is going to be a major focus and priority, but really we should talk about configurability. We don't have to start anything from scratch, or most of the things at least from scratch. We do have nuggets of really good information but how we combine that information and how we work together is going to be crucial in terms of responding properly to the ever-changing world around us instead of reacting to it. Building Smart is an international organization. I'm wearing my hat working with this organization today. And for me, Building Smart is really a fantastic hub of international industry experts and professionals. We work in an accelerated fashion where the idea is that, yes, of course, we can solve the problems individually, but it will take way more time than solving the problems together. We really do not have that time. We cannot afford that time anymore. So in my opinion, organizations like Building Smart are crucial in coming together, looking at our common problems and finding solutions for that, but not just finding it in one specific area in terms of the industry, but also cross-pollinating and learning from other industries. So in Building Smart, for example, we learn a lot from what the rail industry has been doing. And we can learn a lot from their success and problem solving as well. This diagram on the left shows just some of the topics that we tackle together in the airport room. Digital twins is one of them. I will mention data security and the BIM to GIS connection in a few minutes as well. I wanted to bring you some great examples from our airport community, from our airport room steering committee members. This example is from Auckland International Airport. And the reason I brought it to you is that this, in my opinion, is a great example of showing data that is actionable and showing data in a way where it's easy to access. It's not specific to a domain. You don't have to be a subject matter expert to understand what is going on, but it's more democratized for the benefit of all stakeholders that need to make decisions based on this information. So in this case, we're looking at an information dashboard that Auckland International uses to make decisions about how the buildings are developed and how they're functioning and what are the uses of those buildings. Another example would be from, this could be typical to any airport, but I have witnessed a great implementation of this at San Francisco International Airport, where the airport is using current technology, which is called geofencing. It's part of GIS. But you can imagine this geofence as a virtual perimeter around the airport, which can sense if vehicles cross the perimeter or not. This is an instrument that they can use in collaboration with car sharing services like Uber, where they can really optimize and monitor the best and most optimal delivery of service to their passengers. It has been a problem and will continue to be a problem for all airports that congestions appear on the curbside. But with technologies like this, they can really optimize the use of how the services can mitigate those issues. One of my favorite examples is from Vienna Airport, where the airport is actively collaborating with the local transportation systems and municipal authorities. They actually are able to be so sensitive that if an international flight comes in, they will know ahead of time that there's a large number of passengers that are coming to a particular part of the terminal building, so they can adjust the air conditioning ahead of time, just in time accordingly. But not only that, they also work with the local metro trains. So if the traffic is reversed and a large number of passengers are arriving at the airport, they know it ahead of time and they can optimize their building systems to respond to that. And in this case as well, respond is a key word. So these are, in my opinion, really good examples of what we could do in the future in a better, more integrated more cross-pollinated way. So finally, I wanted to mention two major initiatives within the airport room that we are working on. One is related to data security. We believe that that is going to be an important subject to tackle for a number of reasons. One of it is that airports, as many other industries, are very competitive. And because of that, everybody is interested in learning about new solutions, but not a lot of people are confident enough to share what their organizations have been up to, in fear of revealing data that would limit their competitive advantage. We are developing a framework where we know what the subject is in that context, so all of our participating member airports can more confidently share information with each other for the benefit of mutual accelerated problem solving. Of course, data security is also important for machine learning and artificial intelligence. We need to share information with the machine at bulk to gain insights that we can really benefit from. Another example that our group is tackling is the BIM to GIS connection. BIM is something that I believe our audience here is familiar with. GIS is Geospatial Information Systems, which is also a database-driven technology that has been used for even longer than BIM. And it looks at the larger horizontal infrastructure of large organizations and campuses. So we are developing the means and methods of how we can share information seamlessly between these two systems, because eventually we need to democratize data and we need to make it available for the benefit of all of us and for configurable decision-making in the future.
So we just wanted to end the presentation. I think we may have a couple of minutes left. But all the buildings that we're building today will last more than 100 years. Or I hope all the research that I've done and everything that I've seen, that is the case. So the real question that Adam and I would like to leave you with is, will your building be as effective today as it might be in the future? And I think with that, we'll wrap it up. And Matt, I don't know if there's any questions or not, but we'll just call it a wrap.